As citizens of Southwest Florida, we are well aware that water quality is one of the great threats to our economy and to our quality of life. And here on Sanibel, the threat from unnatural water flows, polluted waters from Lake Okeechobee, and untreated runoff in the Caloosahatchee Basin have had negative impacts on our estuary, our beaches, and on our bay for decades. Among the positive news in face of these challenges is that many organizations and individuals have stepped forward and spoken out in search of solutions to the woes that we face. Today, we're fortunate to have as our guest speaker one of the great champions in this long-standing struggle, John Cassani. John is a person who understands the environmental threats we face and has a strong vision for the future. John is a special and a gifted leader. He is a scientist who worked as a deputy director for the Hyacinth Control District of Lee County for 36 years. He is a teacher at Florida Gulf Coast University and a scholar who has published dozens of research articles. John is a strong environmental leader, having founded many organizations in Southwest Florida, including the Southwest Florida Watershed Council, which he continues to chair after, I believe, 16 years. John also is a board member, an advisor, and a supporter of dozens of other community organizations in Lee County. He was one of the original advocates for the land conservation in Lee County and served for 17 years on the Conservation 2020 Land Acquisition Advisory Committee. For all of his outstanding work, John has been honored first for his water conservation leadership by Lee County and the Lee County Board of Commissioners, and by the Everglades Coalition for his work as a grassroots advocate. Now, beyond his experience and honors, John should be recognized for his unique ability to bring information, ideas, and people together, a rare and unique ability in these days. John also has a long and strong vision of what we need to do to deal with our water woes, and he has a vision that grasps the intricacies of Everglades restoration policy and science to the practical importance of Lee County politics. It is my honor to present to you a man of knowledge, of steadfast commitment, of experience and vision, John Cassani. John?
It's a real honor to be here. And a pleasure to share some really mutual issues regarding water resources here in Southwest Florida. I see so many familiar people in the audience, the Woodrings, James Evans, the mayor. Many of you could give this talk and probably better than myself, so humbly, it's just really an honor to be here and to share some thoughts. So let's go ahead and start real quick. I've got a few images. Actually, this was a recent image by John Moran. The flows out of the river were so significant recently that they actually got as far up the sound as, I believe this is Blind Pass, so quite an impact. So what I want to do real quick this morning is just talk about some of the estuary issues. There's a lot of links to this whole story, and I thought maybe perhaps your interest in the estuary and its impact on Sanibel might be perhaps more germane this morning. So I'd like to talk a little bit about water quantity and quality and how politics and water policy affect those parameters. I think everyone's aware we're connected to a regional system. Okay, we're not an island ecosystem here, and for better or for worse, we are connected to this regional system. It's operated by the South Florida Water Management District, the Army Corps of Engineers, and multiple local governments at various levels. You all probably recognize that watershed. That's the Caloosahatchee watershed. It's about 1,408 square miles, pretty big watershed. And the rain that falls on this watershed drains to the river and ultimately to the estuary. And for better or for worse, we also get regulatory discharges from Lake Okeechobee. So let's talk about some of the key parameters real quick. One that's particularly pertinent recently and in the past is salinity. I think you're all familiar with this. This is the parameter that actually defines what an estuary is. And that is a linear gradient of salinity going from fresh all the way to oceanic salt water level. In coastal Florida, we have multiple estuaries. Some of these are the most productive and incredible ecosystems on the planet. I think everyone's aware of this statistic. 70% of all our recreationally and commercially important fisheries are dependent on the estuary at some point in their life cycle. It's really kind of the nursery for so many important components to this resource that we think is so special. And what's at stake? There's a lot at stake. Our industry, our tourism industry, our commercial fish and shellfish harvest industry, the boating industry, we're looking at something over $2 billion annual impact in this region. So a lot at stake. One of the key ecosystem components that was identified more than a decade ago when developing the minimum flow and level rule for the Caloosahatchee Estuary was this plant here. You all familiar with it? This is tape grass, sometimes called eelgrass. It's basically a freshwater plant that can take a higher level of salinity. It can take up 10, 15 parts per thousand, but as that duration increases, it's detrimental to the plant. So the scientists at the time said, hey, this is the canary in the coal mine. We're going to identify this plant as something we want to watch carefully in the context of freshwater inflows into the system. This kind of characterizes that salinity envelope that's so important to everything else downstream. So this kind of represents the ideal salinity gradient in the Caloosahatchee Estuary. Okay? This doesn't happen very often. Full strength seawater down here at the mouth, just about fresh water up at the beginning source at S79, the Franklin Lock and Dam. Okay? And that's the kind of salinity gradient that Valsenaria or tape grass really likes. And of course there's some tidal influence daily that changes that to some degree. These are some pictures I took in 1979 when I first started working here. There were about 600 to 1,000 acres of this plant, the shallow shelf areas of the Caloosahatchee Estuary, the upper estuary. You can see I-75 and some areas on the north side of the river, and it was lush. You know, everything out to about 1.5 meters, 2 meters was just lush. Valsenaria, some other species as well. I can remember times being on the river and seeing vast flocks of migratory waterfowl, tens of thousands that would fly up as you would approach them, and they were feeding on these plants. Some of the organisms associated with this plant community. You could drag a seine or a deframe net through here, and you would get pounds and pounds of shrimp and invertebrates and juvenile fish. This was the factory. This is what produced that massive productivity that makes this system so impressive. A very significant component of it. Unfortunately, this is what the salinity looks like later on in the winter. There are competing uses for water in Florida. I hope that's not a new concept to anybody. And as a result, the estuary does not get adequate inflow during the dry season. Pretty much a good part of the dry season we have this kind of condition. So what happened? Okay, the green and the blue lines represent the tape grass relative abundance through time, through a little snippet of time, 1998 to 2007. And for all practical purposes, we lost that community about towards the end of 1999. And it really hasn't restored since that time. We basically get a little bit of regrowth if we have some normal inflow during the winter. But this is what it looks like now. It doesn't represent much in terms of above ground biomass. Okay? That's a pretty significant problem with the upper part of the estuary. So what are we going to do about it? You're all familiar with the Everglades Restoration Program. Told not to use acronyms as part of this talk, which is kind of hard, but this is the comprehensive Everglades Restoration Plan project meant to address the lack of adequate freshwater inflows into the estuary. It's called the C-43 Reservoir. Has anybody not heard of this project? Okay, everyone's pretty familiar with it. It was supposed to break ground in 2007, was supposed to be completed in 2010. It's a little behind schedule. And part of that is due to, our federal partners really haven't stepped up to the plate and really helped us. I think the war in Iraq and some of the other major issues of the time really put a kink in some of the federal flow of money. But for better or for worse, they have not been really good partners on this particular project in the past. So what's the concept here? It's to acquire or capture water during the high flow season, store it, release it during the dry flow or the dry season to meet the minimum flow requirements for this estuary. Very important process. So what we know now is that the project, it's more or less broke ground, is expected to be fully operational in 2026, so it's going to be another decade. And the target storage is estimated to be about 38% of what we actually need. So we're spending about $436 million on about 38% of the target storage. And there will be some other projects that will try to make up that deficit, but just to give you an idea of the scope of this project. When this project is done, it'll be the 10 or 12th largest inland water body in the state of Florida. That's a big project, okay? Kind of puts the problem we're facing into context. So to sum up the low season flow issues, the minimum flow and level rule that the district adopted in 2001, it's been out there for a while now, and the purpose of it was to protect the resource from over-allocation of consumptive uses. 2 consecutive years of salinity getting higher than 10 parts per thousand for more than 30 days, that defines harm. 3 consecutive years, serious harm. 12 of the last 15 years, we've seen exceedances to the rule, and at least 7 consecutive years as a component of that full time period where we've seen exceedance. So really had some significant impacts on the low flow dry season issues with the estuary. Most of you are familiar with the high flows. We have significant problems with the low flow as well. I have to say that the legislative bill that just passed in January, the hurry-up bill that just passed in January, basically says the district cannot deny a consumptive use permit even when it impacts an MFL water body. It's pretty much what's been going on, but it was codfied this year in the water bill. The bill also says that it allows for interbasin transfer of water. I think the legislators know what's coming to Florida. We're about to have another population explosion. Can't limit the consumptive use of water. The water bill also exempts consumptive users from reporting their usage unless the withdrawal is through an 8-inch pump. It's the biggest loophole in the book. It's not really relevant. So we're not going to have the accurate information we need to understand how extensively this resource is being used. All right, let's jump to high flows. This is what the estuary looked like on March 7th, a few weeks ago. Fresh all the way up to the mouth. So that gradient, that salinity gradient now has been compressed to a very narrow zone. You all know this story, right? So all the plants and animals that live up and have adapted to that daily cycle of salinity change due to tidal influence and an intermediate tidal range or salinity range, they're in trouble now. If they can't get downstream and get out of that inhospitable condition, habitat, they're going to be in real trouble. So I think we're going to see some, as this event winds up, we're going to see some rather stark numbers on what's happening to these plants and animals, or what did happen this past season. There's been a lot of talk about water transparency. The fact that it's murky and brown creates a lot of angst with folks. It's absolutely correct that tannins contribute to the brown, murky color of the water. Okay, but there are other issues with that. It increases that intensity of brown, murky color, and that would include suspended solids, dissolved organics, other dissolved organics like tannins, and dissolved metals. A lot of people don't realize that the concentration of iron in the Caloosahatchee has reached near impairment levels, and there's a phenomenon referred to as brownification, so that when iron is that high a concentration, it binds with other components in the water column and creates a darker, browner image. So now instead of looking at a dark tea color, we're looking at coffee color. Okay, so there's an explanation for some of that. What this graph is showing you is the penetration of light through the water column of San Carlos Bay just over here, where we used to have some pretty incredible historic seagrass beds. And we know that the seagrass needs light. The deeper the water, more restricted light, it limits its distribution. Okay. One of the concerns was, is it darker and murkier than it used to be? Has the transparency decreased? And I think the answer is yes, through time it has. This only shows 2000 through 2015, but that orange line there represents the transparency that occurred in the historic deep edge of seagrass in San Carlos Bay. We're not anywhere close to that now. So it has gotten darker through time. Transparency has decreased a lot. Are there other impacts from these flows? Certainly. A very significant paper study modeling effort put out by the Florida Realtors Association this year indicated that for every foot of lost transparency, it has a $500 million impact on Lee County's real estate values. Very significant impact. There are so many other issues too. We have dissolved oxygen issues, there's pharmaceuticals in the water, metals like mercury, bacteria and viruses. There's really a whole smorgasbord of issues related to water quality. I'm not going to spend too much time on them this morning. Franklin Lock Beach has just been closed because of bacterial contamination. So we have these ongoing problems on all these other parameters as well. The 2016 water bill identified that, or codified that, agricultural interests following BMPs that are best management practices cannot be held liable for the impacts of their activities. The same bill exempts rulemaking for verification of BMPs and subsequent monitoring. You probably ask yourself why. You know? Well, think about that for a minute. The same bill establishes 20-year deadlines for compliance on TMDLs and MFLs. These are the kind of regulations that we need to start getting a grip on restoration, progress on restoration. Probably one of the biggest issues that you all are familiar with is nutrient enrichment. It creates problems. And what's the biggest manifestation? Algal blooms. Okay? Lots of problems with algal blooms. These are what we call cyanoblooms, or blue-green algae blooms. And they produce a neurotoxin when the cell lyses. And from time to time, they do bloom in the Caloosahatchee estuary. They do shut down the water treatment plant at Olga from time to time. They do close beaches from time to time. Well, one really serious issue that's coming to light more recently is the impact that these neurotoxins have on neurodegenerative disorders in people. We're talking about Alzheimer's, Parkinson's, ALS. It's a very, very strong link to those problems. There's empirical research out there now that demonstrates some important concepts here. Dr. Larry Brand, University of Miami, has studied fish and shellfish in the Caloosahatchee estuary, and he's determined that this neurotoxin known as BMAA is in moderate to high levels. It bioaccumulates like heavy metals in the food chain. It's a pretty significant problem. And he concluded that it's predicted that human exposure to this particular neurotoxin will increase, and leading to possible increased incidence of neurodegenerative diseases such as Alzheimer's, et cetera, et cetera. So I know some people that are researching this now. There's going to be more information on this in the future, and you really want to stay tuned to this one. Breaking news in January, first time scientists from the Institute for ethnomedicine has determined that there's now a direct connection of this neurotoxin to brain tangles in animals that are exposed to this particular environmental toxin. It's really, really a bad thing. So what are the future issues? I'm going to wind up here pretty quick. These are the things that really, really, really concern me, the future issues. Climate change is one of them. The governor says staff can't use that term. Can't be using that term, it's a bit of a problem. So the big question becomes, can coastal ecosystems and economies adapt quick enough? I just read something, breaking news, Dr. Jim Hansen, who studies climate change and some of the progressions on this issue. It's always happening quicker than what the models had predicted. So it's coming, and it's coming quicker than we thought. Florida is probably more vulnerable than any other state, particularly the barrier islands. We're getting another population explosion. We're back up to almost 1,000 people a day moving to Florida again. You were talking about traffic issues. And our governor's in the State of the State address is going up north and inviting more folks to move to Florida. I think we need to do a little better planning before we invite another mass wave of residents to the state. We love them all, but it's a kind of a mixed message. So I'm going to take you on a little visual journey and tell you and show you visually how a watershed can build out in a relatively short period of time. This is Central Cape Coral looking north from Veterans Parkway. We know that when a watershed gets to about 10% impervious, roads and rooftops, what happens? Water quality declines. What year do you think this is? Any ideas? No ideas. Central Cape Coral. 75. Actually, this was 1986. What do you think the impervious cover was in this sub-basin in 1986? Probably less than 5%, probably. Let's jump to 1998. What do you think the percent impervious is now? Probably pushing that magic 10%, maybe more, maybe 15, 20%. Let's jump a few more years. Same view, 2004. Now we want to concentrate, if that many residents are going to live here, we want to see a concentration in an urban core, but there are consequences. The same progression of growth is occurring in the North Cape. Okay? Matlacha Pass was declared impaired for nutrients this past August. No coincidence. The Caloosahatchee estuary was impaired for nutrients in 2009, if I remember correctly. So there are consequences to these things. If you were looking down on this in 2012, it would look like this. This is build out, folks. This is build out. This is the watershed for the tidal basin, Caloosahatchee estuary. Kind of let those boundaries sink in a little bit. I'm going to take you through a visual journey of how this basin has built out through time. Let's look at 1960. Anybody in this room lived here in 1960? I bet the Woodrings did. Yep, we got one. The last time I gave this presentation, there was another one in the room. That was Frank Mary Lee Mann. Lived here in 1960. It's a good time to be here, right? It's a good time to be here. Let's jump 20 years and let's see how that tidal basin watershed is built out. That big green, by the way, is the density reduction groundwater resource area. Okay, that's what we're trying to preserve. It doesn't run off, rainwater doesn't run off from that into the Caloosahatchee. It goes more towards Estero Bay. But let's look at 1980. Big difference. Look at Sanibel. Let's jump another 20 years. Let's go to 2000. Look at Sanibel. That's about when Sanibel stopped growing at the rate that Lee County is growing now. Let's jump 14 more years. Does this look like the red map that sold the 2020 program in 1995? This is what we were trying to avoid. Conservation 2020 has only bought about 6% of the land mass in Lee County. Okay? You'd be hard pressed to find some of those parcels, even the big ones, on this map. So just to try to put it in context, how much urban development has increased in the context of everything else we're doing. The impacts to our estuary will be staggering, or are staggering. Kind of feel like Bob in this picture. You know, it's really a struggle sometimes with these massive drivers that affect water quality in so many ways. So what are the solutions? I think there's a lot of folks in the room that probably know as well or better than I do. I'll discuss a few of them that are important to me. It's become evident more so than ever recently with the flows that we've had just this past month or two, that we need more storage treatment conveyance north and south of the lake. Remember in 2008, the River of Grass initiative that Governor Chris started, purchased part of the EAA south of the lake? And at that time, the Water Management District thought that was the best thing since sliced bread. Why aren't they anymore? I think you can figure it out. Regulatory compliance. You know, we keep spending all this money on these massive infrastructure projects, and maybe that's the only way. But in the same time, we also need to be requiring compliance and enforcement. Our minimum flow rule is frequently exceeded. It's not addressed due to over-allocation for consumptive uses. Water quality is a problem. The Coosa Estuary has what they call a Basin Management Action Plan, and the county, as one of 7 or 8 stakeholders, is required to reduce nitrogen in that basin by so many pounds a year. At the current rate that they're reducing nitrogen is about 73 pounds a year. They have 94,000 pounds a year to go to meet that Clean Water Act regulatory guidance. Will take over 1,000 years to reach compliance at that rate of nutrient reduction. Okay, so it's not that they can't do better, maybe they will, but we really need to do better on compliance so we're not spending so much money on these massive infrastructure projects. Climate change and population explosion, the perfect storm for Florida. It's coming, it's coming. And we really, really need to plan and be ready for it. What's going to make all this work? You know the answer. It's political change through civic engagement. That's the only way it's going to change. I've learned as a scientist all my life that if there's no political will, there's never going to be enough science to justify policy change. So that's pretty much my story. We have beautiful, beautiful, fantastic resources out there. They're worth fighting for. They're worth standing up for. They're worth advocating for. And we've got to do that. And I'll leave you with that thought.